Hi everyone. Well, as Gonzalo was saying, I'm the current Spyder maintainer, and today I'm going to talk to you about precisely Spyder, which is an interface that I think goes beyond Jupyter to do scientific programming in Python. So to start, let me give you a brief introduction about myself. So yeah, I'm the Spyder maintainer. I have been the maintainer since 2013. Right now, I'm also a software developer at QuantSight. I worked in Anaconda for 3 years. And I'm also a PhD student in industrial engineering here at Los Angeles University. I'm a physicist by training. I learned to code in Mathematica and in C++ many, many years ago. Now, why I think Python became so relevant in science? So during the last 6 years, I think we have witnessed the rise of, first, great libraries. The first one, of course, is Pandas, which we have heard a lot about during this conference, which is basically, or many of you perhaps know it as an excellent asteroid. Then we have also scikit-learn, which became really machine learning for the mazes. And finally, we have TensorFlow and PyTorch, which generalize deep learning for the mazes. But besides that, we also have witnessed the emergence of a fantastic ecosystem of tools to distribute, install, and use these libraries and many other libraries in the Python scientific ecosystem. So the first of these tools is, of course, Anaconda. So Anaconda is not, to me, which have worked developing Anaconda, is not just a Python distribution, but it's a unifying platform to do scientific and engineering applications. And we are very grateful, of course, to Travis Oliphant and Peter Wan for funding Anaconda, the company, and also for funding the people that have worked to create all the packages that compose Anaconda. Now, besides Anaconda, we also have Conda, which is a multi-platform general-purpose package manager for scientific packages. And we owe that to Kyle Franz, Ilan Schnell, and Aaron Muir for that. So one thing that I would like to emphasize here is that, well, there is kind of a conflict between Conda and pip and what package manager you should use. So that's why I want to emphasize these two words, general purpose. So general purpose means that with Conda you can install not only Python libraries, but any other kind of library, or even complete frameworks, or other languages like R or Julia. That's something that you can do with pip. That's one thing. And the other thing is that Conda packages, Conda has a real solver behind it. So it's possible to define constraints and dependencies in a much clearer and simpler way than with pip. So if you're still using pip, I will advise you to switch to Conda, because it will make your life much easier and it will give you much less headaches when dealing with scientific packages. And besides Conda, Anaconda also developed Conda Built. So Conda Built is a build tool that gets scientific packages. So for many years, people tried to use these utils and setup tools to package things like Numpy and SciPy, and that was a big, big headache. And probably Travis knows that the most of all of us here. Now, when Conda Built came, it was a real relief because it was possible to make Python packages depend on, for example, C++ libraries or C libraries or Fortran libraries in a very clear and simple way. And that's still something that is very hard to do with pip. For example, the Arrow project stopped creating wheels for PyArrow because it was very hard to do that in a consistent way. So for PyArrow, it's very hard because they depend on OpenSSL and on several other C++ libraries that had to be packaged inside the wheel. And that can also enter in conflict with other packages that do similar things like TensorFlow. So that's why they stopped doing that. And also, for example, the guys behind the Rapids framework for CUDA, that they also decided to not package wheels because of that. So Conda Built is a really good tool, and that's the tool that you can use to create Conda packages. And so instead of distributing Python packages, you need to use Conda Built to do that. And finally, in this area, or in this space, we have Condor Forge, which is a community of packages that right now has around 8,000 packages, I think. So, and it's only Conda packages, but it has allowed a larger community of contributors and developers to create Conda packages and distribute it to everyone that requires them. So this is a great effort. It took these 3 developers, Felipe Fernandez, John Kirkham, and Jonathan Helmus, about 2 years, I think, to develop. But now it works very well, and it works using continuous integration systems. So you only need to provide what is called a Condor recipe, and then the package is built in the cloud and is uploaded to the Anaconda servers completely by free. And finally, the most important piece of this tooling ecosystem is that now we have mature scientific graphical user interfaces to work with all these fantastic libraries. So obviously the most known one in this space and the most used one, I think, is Jupyter, which was created by Fernando Perez and Brian Granger. And there is also Spyder, which was created by Pierre Roybeau and is maintained by me. And also a team of several developers that are behind it. So these interfaces also allowed to empower users and to allow them to use all these tools in a very friendly and simple to use way. But these 2 graphical interfaces have very different design philosophies. At least that's my perception as a maintainer of Spyder and also a follower of all Jupyter projects, or the most important ones. So I think Jupyter is focused especially on these 2 aspects. First, data exploration. So if you have a set of data and you want to understand it or to plot it very quickly, you can do it in a Jupyter notebook. And also, Jupyter is very, very nice to write computational narratives. So if you need to write a report, or you need to show the results of your research to someone else, then Jupyter is very, very nice for that. And in the case of Spyder, we're mostly focused on programming, on the programming aspect of scientific code. So we also have some of the facilities provided by Jupyter, but we are mostly interested on helping users to program better scientific code. And we also try very, very hard to provide an integrated environment. So probably you have heard many people saying, oh, but Jupyter or Jupyter Labs lacks this feature or lacks that other feature, and adopters of Jupyter say, but you have to install this extension or that extension. Instead, we try to provide something that works from the startup and allows users to be very productive without any additional effort. Now, let me talk to you about the core components of Spyder. But first, let me show you some data. So Spyder is really an acronym that means the Scientific Python Development Environment. It was created by Pierre Roybeau, which is shown in this photo, in 2009. So now Spyder has 10 years. Probably you think it's a younger project, but no, we have been in the market for 2 years. It's MIT licensed. It's also multi-platform, so it works very well on Windows, macOS, and Linux. Right now, it has around 72,000 lines of code, around 100 contributors, and we receive around 50 pull requests and 200 issues per month. These are some additional data. This is our website. It's a very simple website, but it allows you to, it gives a link to Anaconda to install Spyder and also to some other plugins. This is our GitHub website. Right now we have 9 core developers between volunteer and paid developers. Last year we have 2 million downloads on Anaconda and around 350 downloads on PyPI. Now, talking specifically about our core components, well, our cornerstone is really the editor. So, and that's the main difference between Spyder and Jupyter. So the core component of Jupyter is really the notebook. So there are some efforts to try to support, for example, plain text files. I'm working on plain text files, especially in Jupyter Lab. But from my point of view, those don't work very well. In our case, we focus to try to provide a very nice experience in the editor. And for that, we provide code completion with the tab key. We highlight errors in red and warnings in orange. For example, here there is a warning. And here we are showing code completions from this import statement. People can also access documentation using this key binding, Ctrl+I. They can go to the definition of a function using Ctrl+G. And in Spyder 4, this editor is going to be multi-language, which means that we are going to provide this same code completion and linting facilities for other languages, for languages other than Python. So people will be able to have this for C++, for Rust, and for all other languages that support the language server protocol, as I was saying to you yesterday. Now, after you write your code in the editor, you evaluate it in the console. So we have an integrated a panel that provides as many Python consoles as you want. That's a difference not only between, well, Jupyter Lab also provides this, but attached to specific notebooks. But it's a difference between Spyder and many other IDEs. Usually IDEs only provide or give users one console, and you have to work with that only console. Instead, in Spyder, we give users as many consoles as you want, or you can also open one console per file. And in version 4, we will provide special consoles for SciPy, Cython, and PyLab. So SciPy gives you the ability to do symbolic calculations in Spyder, and Cython allows you to write C extensions in Python. So you could work with this directly here. Besides that, we also provide the ability to connect to remote kernels. So if you have a kernel in a remote server that doesn't need to be inside your local network, it could be, for example, in the cloud, and you have SSH access to that server, then we provide users with a configuration dialog that allows them to enter their SSH credentials and connect to that kernel, and that kernel will be attached to a console here, and you will be able to work with that kernel as if we're local. So that's another interesting thing. And from the console, you can also access documentation using this key binding Ctrl+I. But users are not only able to run their code in as many consoles as they want, but they can also select between multiple evaluation modes. So for example, here I'm showing you a configuration dialog for this file, tempi, and you can select to evaluate this file in the current console, in a dedicated console, in an external system terminal, and you can also select between these options. For example, you can remove all variables before execution to always run your code in a clean environment, or you can run directly enter in debugging mode when errors appear during the execution of your code. Besides this kind of configuration that is safe for each file, we also provide the ability to run the entire file using F5 or running cells. This is something that it's easy to explain if you have worked in Matlab. You can break your file in Matlab using these two comments, and in Spyder we added the same functionality by using comments that start with 2 percentages. So that breaks the file in sections, and you can evaluate each section separately using these key bindings, Ctrl-Enter or Shift-Enter. So this works in the same way as in the Jupyter Notebook. So Shift-Enter evaluates the current cell and moves to the next cell, and Ctrl-Enter evaluates the current cell and remains there. So this is something very interesting, but usually people don't know about it. So sometimes I have to go to Stack Overflow and tell people, look, instead of selecting many times the same region of your file with the mouse and running it with F9, which is this last key binding, you can just break it in cells and run each cell separately. And that's about the console. But we also have a variable explorer. So this is the equivalent of the workspace in Matlab. And it has the ability, or it gives users the ability to inspect variables defined in the console. All variables that have been generated in the current run can be shown here. But you can also modify these values graphically. For example, here is a Numpy array, and you can double-click here and modify any value. Besides that, you can copy, plot, and remove variables from here. And something very interesting is that it works while you are debugging. So if you enter debugging mode, you have exactly the same facilities as if you were running your code normally. And finally, the last core component is our HelpPaint, which renders docstrings in rich text mode. So for example, here we have a function from the npmat library that contains an equation written in LaTeX. So we take that docstring, we send it to Sphinx, and Sphinx returns us as a web page, and we simply render that web page here. And you can see that we provide inside the Spyder a copy of the MatJax library. So we are able to render mathematical equations and show it inside this HelpPaint. Now, besides those core components, which, well, some of them are present also in Jupyter Lab and some not, we provide more components that I think will make your life as a scientific programmer very nice. The first one is this finding files component. So usually, as a programmer, you need to look for text in a lot of plain text files. And people that comes from Linux uses tools like AG or ACK. But if you go to Windows, those tools are not very easy to install. So in that case, with Spyder, you can look, for example, in a specific directory, excluding a specific pattern files, and look for a string there, and you get the results here. And what is even nicer about this is that you can double-click in any of these files, and the file will be opened in the editor. Now, we also provide the ability to create projects. So a project is simply a directory that has some metadata added by Spyder on it. And in this directory, you can, when you create and open a project, then you will have a dedicated pane that shows the files only on this project. And the IPython console will also, Spyder adds to the IPython console the Python path of that directory. So if you are developing a project inside this directory, you can run it very easily. You can import it and run it in the Python console very easily. As I told you yesterday, in version 4, we're going to add a plots pane that will allow users to have a history of all the plots generated in the Python console if you have the inline backend. So the inline backend is simply the Matlab backend that renders plots inside the Python console. And users will be able, for example, to change here the zooming of the plot or moving in history, saving these plots or removing them from history. And we also provide an outline pane, which shows all the classes and functions defined in a file. That's very useful to move very quickly among all important objects or methods that you have defined in the file. And in version 4, we also added the ability to nest cells. So for example, here you can see that there is this cell called sensitivity, and that is defined with just 2 percentages. And below it, there is this another cell called precision that has 3 percentages. And in the outlined pane, you can see that precision is inside sensitivity. So it's kind of a nice way also to organize your code and break it in these section called cells, and even be able to have a hierarchy of cells that will allow you to even break in different kind of sections the code that you're writing. And finally, we also have what we call a switcher. So a switcher is a concept that was added by Sublime Text, but now almost all IDEs have it, and this simply by pressing, for example, in our case, Ctrl+P, and you get this very nice widget that allows you to move between the open files in your editor, but we also plan to add, for example, the ability to move between the IPython consoles that you have open, because you can rename every console with a specific name. You will be able to move, between those consoles. And in the future, we also plan to add actions to it. For example, the ability to grab code. So in this case, this code goes over the limit of 78 lines, so you will be able to grab this code and show it over here. So to finish, I would like to mention some advantages and disadvantages both of Spyder and Jupyter Lab. So in the case of Spyder, I think the main advantages is that it provides an integrated experience. So these are not all the panes that are available in Spyder. You will be able also, we provide also a profiler, a debugger, and a breakpoints pane, and a lot of other things. We have, in this moment, like 17 different plugins and panes. The second thing is that Spyder is powerful, but we think it's simple to use. So if you open Spyder and want to write some code and evaluate it, Spyder allows you to do it as quickly as possible. And there is a lot of configurability, as I showed you, but that configurability, we try to select good defaults so that configurability works well for most users most of the time. But still, the configurability is there to change parameters and adjust things as you want. And finally, and something that is probably not considered, but it's important for people that live or that don't speak English and live in other countries like here in Latin America, is that the Spyder interface is translated to 8 languages. And I think among the Pythons in the scientific Python ecosystem, it's probably the only project that has been translated to so many languages. But of course, there are some disadvantages. We have still lots of installation issues. So that's something that consumes my time as a maintainer a lot of time, and it's very boring, very hard to debug sometimes. The most typical case is that people mixes Conda and pip packages. So people, because people try to find a solution, for example, in Stack Overflow, and someone else says, oh, you should use pip to install these or that packages, and that breaks Conda or Anaconda. So that's still something that we are trying to figure out how to fix. At the moment, it's not so easily extensible, so we don't provide an API, a good API to extend it by writing plugins on top of it, but we are working to try to improve that in the future. And our debugger has been criticized, and rightly so, for being very crappy. But we are also working to improve that. I mean, right now we are kind of limited, but some limitation also of the Jupyter architecture, which is what we use as the backend. But hopefully for Spyder 4, the debugger will be much better. Now, in the case of Jupyter, I think the main advantage is that it was really, and still it is revolutionary in the way that allows users to mix text, code, and graphics. That's still a very strong point and something that Spyder is not trying to achieve, and is never going to try to achieve. Jupyter also provides a very clean and simple interface to use, which is very nice. It's multi-platform thanks to the browser, because it runs in multiple browsers, so it skips the headaches of working in different operating systems. And as Lindsay and Damian have told during this conference, there is also Jupyter Hub and Binder, which are very, very nice too. But in my mind, the main disadvantages of Jupyter is that, well, the integration with the operating system is not so good. So that's something that improved a little bit in Jupyter Lab, but still, since it runs in the browser, it's not so easy, for example, to just try to double-click in the file explorer of your operating system and opening a notebook there directly into Jupyter Lab. And another point that I don't like too much and has also been criticized a lot is that important functionality is left for extensions. So that's something that many users struggle sometimes, especially because right now in Jupyter Lab you require npm and yarn, so it's very hard to deal with that. And that's all. Thank you very much for your time.
Gracias, Carlos, por la presentación. Tenemos tiempo para una o dos preguntas. Si alguien tiene preguntas, por favor, levante su mano. Iremos hacia ustedes con el micrófono.
Thanks for your presentation. I have a quick question. Does Spyder have this, like, I don't know how to say like this. Can I use command from bash in Spyder in the Spyder console? Like,
oh yeah. Yes, you can do it in the same way as in Jupyter. I mean, exactly, percentage,
okay,
and the name of the command, and it will work in the IPython console too.
Okay, thanks.
Hi. Can I, in Spyder, update or change the linters for review the code while I writing my code?
Yeah, that's updated automatically. So while you're writing your code, well, every time you press a key in the editor, we send the entire content of the file that you're writing to a server. The server analyzes it and returns warnings and errors for you.
Okay, but I can't change the linters.
You mean using, for example?
Yes, I don't know. For example, I want that my classes doesn't have more of 200 letters, for example. Yes.
Well, in Spyder 4, we're going to provide the ability to select for example, the code style rules, the PP8 rules that you want to apply to your code. And I don't know, that depends on the way that also, in this case, Python style can be extended by providing specific rules. So that depends not directly on Spyder, but on the tools that we use in the background to analyze the code. But if it's possible for those tools, then it's possible also for Spyder.